Hello everyone, this is Shruti Saxena Das, and in today's video we are going to discuss about Quicksort algorithm. Sorting is basically arranging elements in some order, either ascending order or descending orders. So if elements are given and if you want to apply sorting, that means you need to arrange it, okay, in some order. Now there are so many algorithms for performing sorting, but Quicksort is the fastest among them, and that's why the name is Quicksort, because it takes very less time for sorting. It is based on the principle of divide and conquer. So first of all, what it does, it divides the array into subparts, into the smaller parts, and then apply the same algorithm in those parts, then again divide it, and finally it combines the sorted sub arrays and give the answer. So this is the algorithm which we are going to discuss today is Quicksort. So you need to remember this, that this is based on divide and conquer algorithm. So you need to divide or partition the array which is given, and then you have to apply this algorithm. So the first thing will be that you need to choose an element as pivot element. So pivot element will be one element which is present in the array. You can take any element, like you can take either first element or last element or any median element, and we'll call it as pivot element because on the basis of this element we are going to perform partitioning. Okay, so you can choose any element as pivot element. So you have to choose an element as pivot, and you have to partition the given array according to the chosen pivot element. Okay, according to the pivot element. So on the basis of this pivot element we are going to perform partitioning. So pivot element you can choose, like it depends that whether you want to pick the first element as pivot element, you can take first element as pivot element, or if you want you can choose the last element, always last element as pivot element. Okay, you can pick the last element as pivot, or if you want you can pick random element. As pivot element, or if you want you can pick the median. You can calculate the median of the array and median element as pivot element. It depends, whatever you want you can take. So your code should be according to that. Okay, so in our example, in our algorithm we are going to take the first element as the pivot element. Okay, so we'll start with the algorithm. Suppose, first of all we'll see the example and then we'll move on to the algorithm. Suppose we are having array elements like this: 6, 8, 7, 4, 3, 2. Now these are not arranged in any order and we have to apply sorting technique. So for that we are using Quicksort. So in Quicksort, the first step is you have to choose pivot element. So as I said that in our example we are going to take the first number or first element as the pivot element. So this is the pivot element in our case. Secondly, we'll take two variables, first and last. So first means the first element of the array, last will point to the last element of the array. So as this is an array, index must be starting from 0. Okay, so I'm taking one variable as first is 0, last is 5. Okay, these are the variables which are holding the value of the index. So first is 0, last is 5. Now if first is less than last, okay, if you are having elements in the array, then only first will be less than last. If first is less than last, then what I am going to do, I am going to perform partitioning. Okay, so here 0 is less than 5. So if your first is less than last, then what I am going to do, I am going to perform partitioning. So for partitioning, what I'll do, these are the elements. What I have to do, first thing is that I'll take one variable as I will be first plus 1. That means in this case I will be, first is 0, so I value will be 1. 0 plus 1, 1. Okay, and I'll take j. Okay, j I'll initialize later. I'll take one element as pivot element, and I'll give it, suppose this array name is A, so I'll give it like this. Pivot is equals to A of first. What is the value of first? First we have taken as 0, so A of 0 is pivot element. A of 0, what is A of 0? 6. So 6 is our pivot element. Okay, this is the case. So till now I have taken 4 variables. First, which is holding the index, the first index of the array. Last, which is holding the last index of the array. I, which is one variable which is holding the index of the next element of first. First is 0, so I will be first plus 1, so I is 1. Okay, so what I am going to do now, that I'll start from here till here. We have to start a loop from here, and we have to move that loop till the last element of the array, and each time we are going to compare the element with the pivot element. So in case it is less than pivot, okay, this element is less than pivot, then what we have to do, we have to swap the values of I and j. So j is the loop which we are taking from here till here, and we'll replace it with the value of I. Now see what we are going to do. First I'll explain this example. See, this is the array which is given 6, 8, 7, 4, 3, 2. We have taken 6 as the pivot element. This is the pivot element. This is first, this is last, and this is the value of I. Okay, first plus 1 is I. Now what you have to do, we'll start j loop from here only. J also from here till last. It should go till last. Each time we are going to compare it with the value of pivot. That means with 6. Now when we'll compare 8 with 6, 8 is not smaller than 6. So we are not going to replace it. Okay, simply j will move to 7. So I'll write it over here. 6, 8, 7, 4, 3, 2. I is still here. J will move to this part. Now again we'll check whether 7 is less than 6 or not. 6 is the pivot. So 6 is pivot element and 7 is not less than 6. Then simply j will move to the next element. J will come here. Now when you will compare it with pivot element, the value of j, a of j with pivot element, what will happen? Now this time 4 is less than 6. So what you have to do, if array of j is less than pivot element, in that case you have to swap the value of a of I with a of j. So a of I, what is I is still here. So a of I with a of j. So what will happen? 6, 4, 7, 8, 3, 2. This will happen. Okay, and if you are swapping, every time you swap you have to increment the value of I. Okay, so what we are going to do, I value will be incremented by 1, so it will come here. and j was already here, so it will be incremented by 1 and it will come here. Again we'll compare 3 with 6. Now this one is also less than the pivot element. 3 is less than 6. So what will happen? Again swapping will occur between a of I and a of j. So 6, 4, 3 will come here, 7 will come here, and 2. And as we have done swapping, I value will be increased again. So I will come here, j will reach here. Okay. Now we'll again compare 2 with 6. If 2 is smaller than 6, in that case, again I value will be swapped with the a of j. So 2, 7, 8. Okay. Now j will be incremented and I will also be incremented because it is we have done swapping. Now in this case you can see that j loop, I said that it should run from I plus 1 till last. Okay, it should run first plus 1 from first plus 1 till last. Now j value is incremented from last also. Okay, so what will happen in this case, the loop will become false and here the loop will stop. When loop will stop, what you have to do, you have to swap a of first with a of I minus 1. So you have to swap a of first with a of I minus 1. This is what you have to do. A of first means first was pointing to 6. So a of first means a of 0. A of 0 means 6. So we have to swap 6. And what is I minus 1? I is here on 7. I minus 1 means this element. Okay, a of I minus 1 means 2. So we have to swap 6 and 2. So finally what will come? The elements will be like this. 2, 4, 3, 6, 7, 8. Okay, so all the elements which are lying in the left of pivot element and all the elements lying on the right of pivot elements are 2 categories. Okay, so again you have to apply quicksort on this and again you have to apply quicksort on this. So again we'll consider this as the array 2, 4, 6, 2, 4, 3. 2 will become pivot element and these 2 will be 4 and 3 will be the elements. Again you have to do the same thing. You have to take I, you have to take j, you have to take first, last. Okay, so finally when you'll sort it, you'll get the answer as 2, 3, 4 and this will be 7, 8 only. So when you'll combine it, combine the whole result, you'll get the sorted array. So this is the case in quicksort, that you have to choose. The first step is you have to choose the pivot element. The second step is you have to initialize these values, okay, which we have taken first as 0, last as the last index. Then in case first is less than last, then what we have to do, we have to take one I will be first plus 1. Then we have to take one loop j will start from the first plus 1 till last. Every time we have to check a of j with pivot element. If a of j is less than pivot element, then in that case you have to swap the values of a of I and a of j. Okay, so that is what you have to do. Now I'll write the algorithm. So algorithm says, or the code I'm writing for quick sorting. So here we need 3 arguments. First one will be the array which contains the element which you need to sort. Then first 2 variables we are passing, first and last. As I said, first will hold, first variable will hold the value of the first index and last will hold the index of the last element. And if first is less than last, that means if elements are existing in the array, in that case what we are going to do, we are going to perform partitioning. So we have created separate method for partition. Okay, and we are using recursion. As I said, that once you will perform partition, once you will get two sub arrays, then you can perform you can use recursion and perform quick sorting on those sub arrays. So if suppose you are having 100 of elements, then it will be partitioned into 50-50. Then those 50-50 will be partitioned into 4, 25, 25, 25, 25. Like that, this algorithm is going to work. So p plus 1 comma last. So this is what we did. That, see, in P we were getting the value of the element after swapping. That means the I minus 1 value. I was at 7. If you remember, if you see, I is at 7. I minus 1 means this value. I minus 1 means 0, 1, 2, 3. 3. So it is going to return 3 over here in P. Okay, that we'll see. Okay, first of all, you see the code for partitioning. See, partition is a function which is again going to take 3 arguments. It is going to take array, then 2 variables, first and last. Okay, and in this we'll take one variable I, which will be holding the value of first plus 1. First is having the first index value. I will be next to the first index. So if first is 0, I will be 1. If first is 1, I will be 2. Okay, so as we are taking, in our case, we are taking first element as pivot element. So I'm writing int pivot. I'm taking one variable whose name is pivot. It's just holding the value of a of first. That means first is 0, so a of 0, the first element. In case if you want to take last element as pivot, then you have to write a of last over here. So we'll take a loop after this, and J will start with the after pivot. Okay, I'm taking first element as pivot, so from the second element I'm running this loop, and this will run to the last element, and every time I'm performing increment operator. And what I'm checking, if array of J is less than pivot element, then what I'm doing, I'm swapping a of I with a of J. Okay, and I'm incrementing the value of I by 1. I'm incrementing the value of I by 1 every time when swapping is occurring. And once this is finished, once this J loop is finished, J loop becomes false, this condition becomes false, and we are coming out of this loop. At that time, I'm swapping the value of pivot element. Okay, that means a of first with a of I minus 1. Okay, and I'm returning the I minus 1 value. Okay, this is what we are doing. This is what we are doing. Swap here, for swapping I have written swap a of I comma a of j. In case if you do not want to write swap, basically here swap is a function which you need to define. Okay, swap a of I comma a of j means you can take any temporary variable and you can simply use temp equals to a of I equals to a of j equals to temp. That code, that is very simple code of swapping two variables using temporary variable, that you can write it down on your own. Okay, so this is what we are doing over here. That, see, sorting will start, quick sort will start from here. So here what we are doing, we are taking first as 0, we are taking last as the last index, in our example, last index is 5. So if first is less than last, then what we are doing? We are calling the function partition. We are passing the value of array, first index and last index, and whatever value is returned will be saved in this variable p. Okay, in partitioning, again see what we are doing. In partitioning, you have to take two variables, first and last. These two variables are passed as argument. I will be holding the value of first plus 1. Pivot, as in our code we are taking the first element as pivot, so a of first will be pivot. We are running our loop from j to last. You can see the example. Okay, see what we are doing here. In the code it is written that pivot is a of first, that means it will be 6. Then we are running our loop from first plus 1. This is first, so this will be first plus 1. From here till j less than equals to last, that means till here j loop should run, and every time we need to check whether a of j is less than pivot or not. If it is less than pivot, then we need to swap a of I with a of j. So we'll check 8 with 6. 8 is not less than 6, then simply j plus plus, j will come here. Then again you'll check a of j with pivot. 7 is not less than 6, j will move further, j will come here. When you'll check array of j with pivot, now this time 4 is less than 6. So in that case what will happen? See the code. In case if array of j is less than pivot, then in that case you have to swap a of I and a of j. That means here, see in this case, if a of j is less than pivot, then in that case you have to swap a of I with a of j. That means 4 will come here, 8 will come here. Okay, and you have to increment the value of j by 1 and I by 1. So I plus plus, j plus plus. That is what we are doing in this quicksort. And once it is done, once the loop reaches j less than equals to last condition will be fulfilled, at that time you'll come out of the loop, and after coming out of the loop you have to perform this operation, this statement you have to execute. That means we have to swap a of first. What is a of first? 6. A of I minus 1. What is a of I? See, I we incremented, I reached here. A of I minus 1 means 2. So we have to swap 6 with 2. So 2 will come here, 6 will come here. So that is what we discussed, that we'll get something like this. 2 will come here, 6 will come here, and after swapping these two values, when pivot will reach in the center, in the left you'll be having all the values less than pivot, and in the right you'll be having all the values greater than pivot. And again quick sorting will be applied. See, we are using recursion. The name of the function is Quicksort, and here we are calling Quicksort. So again the same function will be called. That means we are using recursion for this. So using recursion, again Quicksort will be applied on this partition and this partition simultaneously. Okay, so like this it will go on until you get the answer. So I hope this algorithm must be clear. In case of any confusion, you can drop your queries in the comment box. Thank you so much.